Hello. Neurons are cells that, among other things, allow living organisms to quickly respond to various situations and support the vital functions of the organism. Most representatives of the animal world have neurons in their bodies. Neurons can be located in various parts of the body. Sometimes there are very few neurons. For example, in one species of nematode, there are 302 neurons in males and 385 in females. Yes, it's true. Females are more learned. There are organisms that, although they belong to the animal kingdom, do not have neurons. For instance, sea sponges. As for humans, we have about 85 billion neurons. Seems like a lot, but elephants have 250 billion. So never brag about your intelligence in front of elephants. But now we will not talk about animals with a large number of neurons. Let's consider ordinary beetles. For example, beetles, ladybugs. There are no exact numbers, but they have about 1 million neurons in their body. Why not try step by step to reproduce the behavior of beetles in different situations using machine learning and other methods? Throughout the video series, we will be training our beetles using Python. Now you see on the screen my students who are walking around and eating hamburgers. Yes, beetles love hamburgers. Didn't you know about it? Our beetles definitely love them. And they don't get fat. Hey. But now the beetles' movements are completely chaotic. They don't have a brain. Their movements are controlled by a random number generator. They only eat a hamburger when they bump into it. In other words, they behave like me in a shopping mall. But while you can't change me, you can still teach the beetles something. Let's give the beetles the ability to see hamburgers. Now the beetles can see the food in a certain sector in front of them. Outside of their sector, they see nothing. The students know the distance to the food and the angle between their direction and the food. Let's display this on the screen. Oh no! Visualization tools in the Pigame library are far from ideal. Let's exchange this carnival for something more prosaic. Now in front of the beetle appears a vision direction area when it senses food nearby. But now we need to teach the beetle to react to what it sees. Let's insert a neural network into the beetle. The network will consist of 2 inputs and 3 outputs. The input will be the distance to the food and the angle to it. We will receive one of the possible 3 actions of the beetle. In one move, it can turn right or left at a slight angle or move straight. If the beetle reduces the distance to the food or turns towards it, we will reward it. On the contrary, if its position relative to the food worsens, we will penalize it. Just like in school during my childhood. Maybe that's why I behave this way in shopping malls now. But let's start training. For training, we use the reinforcement learning method, namely DDQN. Set the length and angle of the beetle's vision sector and start training. We train 5 beetles at the same time. Data from all beetles goes to one brain, which controls each of the beetles. That's their superpower. After a while, we check the behavior of our smart beetle compared to the brainless one. In the upper left, you can see the number of hamburgers each beetle has eaten. He's not particularly effective. Collects less than the brainless one. We'll have to fix bugs in the code. As a result of training, we selected an aesthetic beetle. He likes to admire food. looking for bugs in the code again. Let's try to train one beetle, not 5. The fact is that if you teach 5 at once, it leads to situations that negatively affect training. For example, a beetle sees food and heads towards it. But at the same time, a second beetle also saw the same food, approaches faster, and eats it first. Then the first beetle gets penalized because the food disappeared from its field of vision. And this negatively affects the quality of training. In general, reinforcement learning, as it is called in the IT sphere, is full of surprises. Here, for example, we test one of the trained beetle variants. The beetle runs well for food. But there is a nuance. I gave the beetle a very narrow vision sector for food. So when he sees a hamburger, he just rushes forward and still eats it. He doesn't need to turn. He didn't even learn to turn. But when I increase the angle, this behavior immediately becomes losing. The food appears too far to the side of the beetle's direction, and he flies past the burger, drooling. I'll try to teach beetles by giving them a bonus for reducing the angle between the beetle's direction and the food, or the distance to the food. At first the training goes well, but then the beetle mutates. As a result, he waves his head in front of the food without approaching it. There could be many reasons for such behavior. I'm not going to delve deeply into the causes and do it differently. I changed the basic movements of the beetle. Now the beetle not only turns to the sides, but also turns and takes a step. Or just takes a step straight. And I give him a reward for approaching the food or getting it. I penalize if the food disappears from the sector. And I ignore it under all other conditions. The beetle learns perfectly. The result is 4 times better than with random movements. Maybe it's not that much, but I remind you. When the beetle does not see food, it moves randomly. Moreover, the neural network has only 2 inputs. So I am satisfied with the result. Now I move on to more complex and interesting experiments. In the next video, we will add not only hamburgers, but also poisonous mushrooms.
He's a madman.
And maybe change the relief of the training field. But for now, let's relax with the beetles at a picnic. Beetles, don't go too far. Pizza is coming. What are you doing? Where are you dragging me?